Jai Jagannath, welcome to lecture number 5 of electric potential. You see, today we will discuss some problems. In this lecture, we will discuss more problems, basic problems. So here, you see, exercise 23.29. A total charge of 3.5 nanocoulomb is distributed over the surface of a metal sphere with radius 24 centimeter. You see, suppose this is a metallic spherical conductor. So here the total charge is uniformly distributed, and for a metallic conductor the total charge will distributed on the surface. They will lie in the surface. So what is the total charge? Total charge given is equal to 3.5 nanocoulomb. Nano means 10 to the power minus 9 nanocoulomb. And what is the radius of this sphere? The radius of the sphere is r. So r is equal to 24 centimeter. So I am writing the radius is 24 centimeter means 0.24 meter, and charge is given 3.5 nanocoulomb minus 9 coulomb. So if potential is 0 at infinity, so generally we take potential at infinity point is 0, then you have to find potential at a distance of 48 centimeter, 24 centimeter, 12 centimeter from the center. Suppose first point is 48 centimeter, so radius is 24 centimeter. That means this point, let us say this point is your A. So this A point is at what distance? 48 centimeter from the center. That means this A point is the external point. Similarly, you have to find potential at 24 centimeter. So radius is 24 centimeter means the point B is lying on the surface. Point B is lying in the surface. And you have to take potential at 12 centimeter means 12 centimeter is the inside point. So here the distance between the center to the C point is what? 12 centimeter. So first we will find what is the potential at A point, which is equal to potential at external point for a spherical conductor. And for a spherical conductor, the potential at external point is equal to KQ by R. R is the distance. So K is 9 into 10 to the power 9. Q is given 3.5 into 10 to the power minus 9 divided by from center to this A point is 48 centimeter, that is 0.48 meter. So if you will calculate, you will get 65.625 volt. So this is the potential at A point. Come to second point, that is potential at 24 centimeter. 24 centimeter is nothing but the point on the surface. And what is the formula of potential at the surface? It is KQ by radius of the sphere. So K is 9 into 10 to the power 9. Charge is 3.5 10 to the power minus 9 divided by radius. Radius of the sphere is 0.24 meter. So if we will calculate, I think it will come 131.25 volt. Now at C point is the internal point. So that is internal point. And the C point is at 12 centimeter from the center. But we know potential on the surface is equal to potential at the internal point. We have derived in the derivation of this potential due to internal point and potential due to surface, all are equal. That is, potential at internal point is the same as potential on the surface, and already we know potential on the surface is 131.25 volt. So at internal point also the potential is equal to 135.25 volt. So this is a question. Here it is given two concentric spherical cells of radius 1 centimeter and 2 centimeter. You see, so I am taking two concentric cells. So this is the inner cell and this is the outer cell. So in the inner cell, the radius is 1 centimeter, and the outer shell radius is equal to 2 centimeter, and inner shell is charged by 4 nanocoulomb. And here you see in the inner shell the total charge of 4 nanocoulomb are distributed, and in the outer surface of the outer shell, spherical shell, is distributed by charge of -6 nanocoulomb. Let us say this is your Q1, this is Q2. So here you see the Q1 is equal to 4 nanocoulomb, nano means 10 to the power -9, and Q2 is equal to -6 nanocoulomb, that is 10 to the power -9 coulomb. The internal radius is equal to 1 centimeter, so which is equal to 10 to the power -2 meter. The external radius is R2, which is equal to 2 centimeter, that is 2 into 10 to the power -2 meter. Okay, so first we have to find the potential at R is equal to 0.5 centimeter. So you see the radius of the inner sphere is 1 centimeter. So from the center, if we take 0.5, then this 0.5 is nothing but the internal point. Let us say this is your first point, which is at what distance from the center? It is 0.5 centimeter from the center. So now what is the potential at 1 point? Now you know potential is a scalar quantity, so we will add the total potential at a point algebraically. Now first find out what is the potential at 1 due to first sphere. Okay, so I am taking, suppose this is A point, you take this is A point. So potential at A point due to first surface plus potential at A due to second charge sphere. So this point is internal point for this sphere, and we know at internal point potential is same as that of the surface. So here we can write the potential at A due to inner sphere is equal to K Q1 by the surface distance. Surface distance is equal to, let us say, R1. So because on the surface potential is the same as that of the internal point. So on the surface the distance from the center is 1 centimeter. So here K Q1 by R1 plus K Q2. So this is the outer sphere, K Q2 by, you know, this A point is the internal point for this outer sphere. And since we know the potential on the surface is equal to potential at internal point, so I have to write K Q2 by this radius. What is the radius of the outer sphere? 2. So that is equal to K is 9 into 10 to the power 9, Q1 is equal to 4 nanocoulomb divided by R1 is equal to 1 centimeter, 0.01 meter, plus Q2. So here you have to take Q2 is equal to -6 nanocoulomb divided by the distance R2 is equal to 0.02. So if we will calculate, I think it will come 900 volt. So this is the potential at A point. Come to second bit. Second bit, the potential at R is equal to 1 centimeter. Potential at R is equal to 1 centimeter. You see R is equal to 1 centimeter means this is the point B. So this B point is the point on the surface of internal sphere, and this B point is the internal point for the outer sphere. So we can say the potential at B due to first sphere plus potential at B due to second sphere. And since the point is lying on the surface of the internal sphere, so it is K Q1 by, so I am directly writing the formula. K is what? 9 into 10 to the power 9 into Q1 is equal to what? 4 nanocoulomb divided by, this is on the surface, what is the radius? 0.1 centimeter, plus Q2 is equal to what? -6 nanocoulomb, And you see this B point is the internal point for this outer sphere. So you know for a sphere the potential on the surface is equal to potential at internal point. So potential at internal point B is same as potential on the surface. What is the potential on the surface? KQ2 by the radius. Radius is what? 2 centimeter, 0.02 meter. So just calculate this. So I think you will get it is 900 volt. Similarly, calculate the potential at what distance? 1.5 centimeter. Potential at 1.5 centimeter. So you see, if I'll take the C point, I'll take a point. So this is my point C. So this C point is at what distance? 1.5 centimeter. That means this C point is the internal point for the outer sphere and external point for the inner sphere. So we have to find the potential at C due to first sphere, potential at C due to second sphere. So C point is the external point for this inner sphere. Then what is the formula? KQ1 by R. R is the distance from the center to this point, and this point is the internal point for the surface. So that is for this sphere. So for this sphere, potential on the surface is same as potential on the internal point. So that is KQ2 by the radius is R2. So just put the formula. 9 into 10 to the power 9, Q1 is 4 nanocoulomb, divided by this point to this point distance is 1.5 centimeter, that is 10 to the power minus 2 meter, plus Q2 is equal to minus 6 into 10 to the power minus 9, divided by 2 into 10 to the power minus 2. So calculate this. So if you calculate, you will get, I think it is minus 300 volt. So in this way, you can calculate the potential at 2 centimeter, 3 centimeter like this. Okay. So I am giving the answer. You can match it. So now you find potential at R is equal to 2 centimeter. So I am writing you already know. So 2 centimeter in the surface of the second sphere, and 2 centimeter is the external point for this inner sphere. So that is equal to K 9 into 10 to the power 9. Q1 is equal to 4 nanocoulomb. And this point is at 2 centimeter. That is 2 into 10 to the power minus 2 plus Q2 is minus 6 nanocoulomb, divided by this point is lying on the surface, so 2 10 to the power minus 2 meter. So if you calculate, you will get minus 900 volt. Similarly, last bit is you have to find the potential at R is equal to 3 centimeter. So R is equal to 3 centimeter means this point is lying outside to this sphere. So here the formula will be 9 into 10 to the power 9, Q1 4 into 10 to the power minus 9, divided by from this point to this point, external point, distance is 3 centimeter. So plus Q2 divided by, for second sphere also this is external point, so 3 into 10 to the power minus 2 meter. So again if you calculate, I think it will come minus 600 volt. Now see, earthing of conductor. So this is a spherical conductor. The outer surface is connected to the earth by a conductor. So that is called earth connection. So here you know the potential, we generally take potential in the earth surface is 0. So if the potential on the earth surface is 0 and it is connected to the surface of the conductor, then we can say the potential at earth is also equal to the potential on the conducting surface. So that means the potential on the conducting surface is also 0. So if this is the surface, so here potential on the surface is also equal to 0 because it is connected to the earth whose potential is also 0. But it does not mean that the charge on this sphere will be 0. So that does not mean that charge may be 0, may not be 0. So we will take an example so that it will be clear. If the potential on a conductor is 0, that does not mean that charge on that conductor will be 0. So this is a question you see. Just I was telling, if any conductor is connected to earth, it does not mean that the charge on that conducting surface will be 0. So this is an example, you see. So there are 3 concentric spherical cells. So inner cell is A, outer cell is C, middle cell is B, and this B cell is connected to the earth. So if the charge on this A cell is Q, charge on the C cell is equal to 2Q, question is find the charge on B. So we don't know what is the charge on B. Let us say charge on B is equal to Q. Okay. So now see, we can write let charge on B sphere is equal to Q. Say. Now you see, I have to find what is the potential at B point. Potential on the surface of the B sphere is equal to what? So this point or the surface of B sphere, that point is external for this A sphere and on the surface for this B sphere and the internal point for the C sphere. So we can find the potential on the B is equal to potential due to A sphere. For this A sphere, it is external point, and potential due to charge at B sphere, it is on the surface, and potential due to C sphere, for C sphere this point is your internal point. So now what is the potential at this due to A sphere? So what is the radius? Let us say the radius is equal to, here it is given. Here the inner sphere radius is r, it is given, and the outer sphere radius is given 4r, and the middle sphere radius is given 2r. This is in this question it is already given. So now we have to find potential at this point due to inner sphere. So that is equal to k q by, what is the distance from this point to this point? 2r, plus potential at this point due to the charge sphere P, that is surface. So you can say the potential at B. So what is the charge at B point? So charge at B point is equal to Q by KQ by, so what is the distance? 2r, plus, so this point is internal point for this charge sphere C. So on the charge sphere, on the surface of the charge sphere, the potential is same as potential at the internal point, that is K. So what is the charge on the C sphere? 2Q. What is the radius of this C sphere? 4r. So this is the value KQ by 2r, KQ by 2r, K2Q by 4r. But we know since the B is connected to earth, the potential on the earth surface is 0. So now you can solve this. That is equal to 0 is equal to K by 2r. K by 2r take common. K by 2r take common. So this is your Q. This is your Q. So you have taken K by 2r. So that is, this is also Q is equal to 0. So that implied Q plus 2Q is equal to 0. That implied Q is equal to minus 2Q. So charge on the B sphere is not equal to 0, though it is connected to the earth. So this is exercise 23.14 of University Physics book. You see, question is like this. So at A point, there are 2 points, A and B. At A point, potential is 200 volt. At B point, potential is 800 volt. So a negative charge of minus 5 microcoulomb of mass is also given. Mass is also given. What is the mass? 2 into 10 to the power minus 4 kg. And what is the charge value? Minus 5 microcoulomb. Micro means 10 to the power minus 6 coulomb. So these two charges, so this charge is moving from A point to B point in the presence of only electric field. So it is given only electric force is present here. So only electric force means electric force is which type of force? It is conservative force, you know. Electric force is conservative force. So if it is conservative force, then we can apply the work energy theorem. We can apply the work energy theorem, or you can say total mechanical energy. Total mechanical energy remains constant for which force? Conservative force. So now at A point the velocity of the charged particle is 5 meter per second. At B point what is the final velocity? That is the question. You see, as per the conservation principle, the total mechanical energy is constant. That means the mechanical energy means potential energy plus kinetic energy remains constant. That is potential energy at B and kinetic energy at B is equal to potential energy at A plus kinetic energy at A. So that implied I can write what is the potential energy at B. What is the charge? Charge is Q. So Q into VB is the potential energy at B plus kinetic energy at B is equal to what? Half m VB square is equal to potential energy at A is equal to what? Q into VA plus kinetic energy at A is equal to what? Half m into VA square. So every data is given, you have to find VB. So I can write half m VB square. Half m VB square is nothing but Q into VA minus VB. Q into VA minus VB plus half m VA square. So that implied, put every data here. Q. What is the value of Q? Q is given minus 5 microcoulomb. Minus 5 microcoulomb. VA is equal to 200 minus VB is equal to 800 plus half mass of the charge particle 2 into 10 to the power minus 4 into velocity of A, that is 5 square. So from this you can find, so here half into mass is equal to what? 2 into 10 to the power minus 4 into VB square is equal to this. So everything you know, you calculate the speed at B point. So if you calculate the speed at B point, you will get, I think the answer will be, let me calculate. .416 meter per second. Now question comes, so which is faster? Definitely at A point speed was 5 meter per second. At B point speed is 7.416 meter per second. That is velocity at B point is greater than velocity of at A point. So at B you will get, at B the speed is faster comparing to A. Without calculating this, we can also see that the velocity at B will be greater than velocity at A. Why? You see, so here this is 200 volt, this is 800 volt. So that means this is at positive potential with respect to this. It is higher than this. So since it is positive, it is negative. Okay, not negative, but with respect to B, it is negative. Okay, so there will be an electric field developed from positive to negative. And this is which charge particle? Negative charge particle. So this negative charge particle will experience a force opposite to that of electric field. That means on this charge particle Q, there will be a force developed which will be L opposite to E. That means the force will produce from A point to B point. if the force direction is from A to B, then acceleration will be along A to B. That means speed will increase. So this is a typical problem. You see, there are two spherical shell. Either A is a solid sphere or hollow sphere, no problem. But B must be a hollow sphere. Okay. So now A and B is connected through by a wire with a switch S. Now here switch is open. Initially switch is open. On the A sphere, the charge distributed is Q having radius R, and the outer shell of radius 4R is distributed by a charge of 4Q uniformly. So what will happen? Question is, when switch is closed, if we close the switch, what will be the charge on both sphere of radius R and 4R? Okay. So let us solve this problem. So I am redrawing the figure. You see. So this is your which sphere? This is A sphere. This is your B sphere. So when switch is closed, what will happen? A and B are closed by a switch. They are connected by a conductor. Switch closed means there is no resistance between A and B. It is a purely conductor. It is short circuited. Okay. So what will happen? So initially at A point there is some potential, at B point there is some potential. So there will be no flow of charge because switch is open. But when switch is closed, what will happen? Some charge will flow from A point to B point, assuming potential at A is greater than potential at B, because at A radius is less, at B radius is more. So we can say the potential at A is greater than potential at B. Let us say. So if potential at A is greater than potential at B, what will happen? The charge will flow from higher potential to lower potential till what? Till the potential becomes equal for both the surface. Suppose you take this is a conductor. At A point potential, at B point potential is VB. So let us say VA is greater than VB. So what will happen? Current or charge will flow from higher potential to lower potential. But this is an instantaneous process. Within very small fraction of second, the potential at each point will be same, so there will be no flow of charge. But if I connect a source, battery, generator, that is called electromotive force, what will happen? There will be a constant potential difference will be maintained in between these two terminals, so that charge will continuously flow. But here there is no external EMF between A and B. It is simply connected by a switch. So what will happen? Immediately charge will flow from A point to B point till the potential of both are same. So it will take within very fraction of second. Okay, this is the logic. Now let after connection, let some charge Q, small charge Q, I am writing. So when switch is closed, let Q amount of charge moves from A to B. Okay. So let Q charge moves from A to B, and within fraction of second, potential at A will be equal to potential at B. Okay. So now if switch is closed, Q charge moves from A to B, then what is the charge on the A sphere? It was initially Q. Now small q charge left from A to B. So what is the net charge on A? Q minus Q. And since small q charge is added to B, then after connection, what is the charge on the B? Charge on the B, initially it was 4Q. Now this Q is added. And what is the condition? So after switching closed, then potential at A is equal to potential at B. Now we will find what is the potential at A point. So at A point, at this point, potential is due to A charge sphere and due to B charge sphere. and this point is the surface point of this A sphere. Then what is the potential at this due to A charge? So what is the charge of A? Q minus Q divided by its radius. For inner sphere, radius is R. Of course, it is K. K into this. Plus, this point is the internal point for this outer sphere. So, you know, for internal point, potential is the same as potential on the surface. So, on B, what is the potential? So, that is K. What is the charge of B? 4Q plus Q divided by, what is the radius? 4R. Because on the surface potential is same as that of internal point. So this is potential at A. Now potential at B is equal to what? Potential at B. So B is the external point for this charge sphere. So what is the charge on this sphere? Q minus Q divided by from this to this. What is the distance? 4R plus this point is the surface point of this B sphere. So what is the potential at this surface? That is K. What is the charge on this B? 4Q plus Q divided by its radius. Radius is 4R. And as per the question, so you know when switch is closed, potential at A is equal to potential at B. So now compare this and VA and VB. So now VA is equal to VB. So that implied this is equal to this. You can say this value will cancel. So that is equal to K Q minus Q by R is equal to K Q minus Q by 4R. Okay. So that implied K cancel, R cancel. So Q minus Q, K by R cancel. Q minus Q by 4. So that is equal to 4Q minus 4Q is equal to Q minus Q. So that is equal to 3Q is equal to 3Q. So that implied, is it correct? Yes. So that implied Q is equal to Q. I see distribution of charge on the surface of thin spherical shell. So you know another concept. Suppose this is a spherical shell, thin spherical shell. So I have shown here. Thin spherical shell means this shell has some thickness. Okay. So here at the center a charge is given Q, and on the thin spherical shell the total charge given is equal to 5Q. Question is how the charge is distributed on the inner surface of the shell and outer surface of the shell. Now see, I have already told for an electrostatic condition, the electric field intensity inside the conductor is 0. So now in the dotted portion, which is internal point of this shell, it has electric field 0. So if electric field is 0 and we can apply the Gauss law for this surface, so using Gauss law, what is Gauss law? Gauss law is that using Gauss law, the electric field or flux, which is nothing but integration of E dot dA over the closed surface is nothing but charge enclosed by the Gaussian surface divided by epsilon naught. So here since electric field intensity inside the shell is 0, so E is 0, integration is 0, that implied charge enclosed by epsilon naught is 0. So that implied a charge enclosed by the Gaussian surface is equal to 0. So here already plus Q is there. So definitely on the inner surface of this shell must have a charge of minus Q, so that plus Q and minus Q will be totally 0 and charge enclosed will be 0. So this is so in this way charge distributed on the inner sphere will be what? Minus Q. But what is the total charge? Total charge is 5Q. If total charge is 5Q, here it is minus Q, then in the outer surface, what will be the charge distributed? So total charge is 5Q. Out of 5Q, already minus Q is distributed in the inner surface. So definitely it will be 6q. So in the cell, the total charge will be 6q minus q is equal to total 5q. So this is your q. Okay. So now in that principle, I can say, I can give you an example here also. Suppose there are two thin spherical cells. So here charge is q, minus 3q is given to this sphere, and 4q charge is given to this sphere. Question is, distribute the charge on each surface of the cell. Okay. So now you see, so I am directly writing. So logically I am taking, you see, this is q. This is the inner cell, and this portion is the, so here in the inner surface of this inner sphere we will have a charge of minus q, because according to this concept, inside the cell electric field is 0. So inside this Gaussian surface total charge must be 0. Since it is q, so minus q will be induced on the inner surface of the inner sphere. Okay. But what is the total charge here? Minus 3q. So here minus q. So now total charge must be what? Total charge must be minus 3q. This is already minus q. So now on the outer sphere, the total charge will be distributed by minus 2q. So this minus 2q, this minus q. Total is minus 3q. But, so what is the charge distributed in the inner surface of the outer sphere? So you see, in the inner surface, if we take the electric field inside the conductor, that is 0. So within the conductor, the total charge must be 0. So here what is the total charge? Total charge is already q minus 3q. That means minus 2q. Total charge within the sphere is minus 2q. But we have to take, using Gauss law, the total charge must be 0. So that means in the inner surface, the total charge will be plus 2q. Okay, because this 2q, and because this 2q and this q and minus 3q, that is minus 2q, will be cancelled. So total charge will be 0. But since the total charge on the outer sphere is 4q, already 2q charge is distributed in the inner surface of the outer sphere. So remaining charge will be distributed of what value? 2q on the outer surface. So I think charge, you got the idea how the charge is distributed. Okay.